Ben, what are you hearing from clients when they realize how much of their software they've never actually inspected after they buy it?
Generally speaking, it's a holy crap moment, right? Because they certainly don't understand the risks associated. A lot of times they don't know where to begin because the problem is so vast. Really, I would say most of our customers think they are doing something. However, once they understand the scope of the problem, right, they realize that they're not doing enough. And then it becomes a question of how do they do more with the resources that they have.
What are the tools they're using today, like the genre of tools that they're using that they think are doing something that is not enough? Like, do you have a sense of that?
Yeah, I think the genre of tools is different specific to industry to a certain degree, right? You have kind of the more traditional means as it relates to how you're managing SBOMs or how you're doing certain tasks within code itself, right? Dynamic analysis, things of that nature, right? Maybe even static analysis. But it's fairly a manual process today. And generally it's point solutions, right, that are taking some form of executable or code and doing some analysis and looking for issues within it. The problem is it's not scalable, right? And the challenge is it's really only looking at a few pieces of the overall risk as it relates to, the device, the application, whatever may be in scope.
And so that would be for the first party code piece. For the third party code, are you seeing kind of the same thing we're seeing where people are maybe putting an over reliance and too much confidence in things like vulnerability scanners and EDR and things like that aren't traditionally built for this software supply chain problem?
Yeah, if you're talking about more downstream, absolutely. Like most organizations don't even have visibility,
yeah.
Right? At best they are. It's a trust exercise as it relates to some sort of, hey, we do this, right? In a document trail that is highly ineffective and doesn't mean anything to be quite clear.
The illusion of third-party risk programs,
sure,
as we like to call it.
Do you have an information security policy? Are you doing these types of tests, right? All of which, is probably not truly happening, and it's definitely not happening to the degree even on the customer's downstream, right?
The self-attestation pinky promise, as we like to call it.
For sure. So, how do you first identify this gap? Why couldn't existing tools solve for it?
I first identified this gap at Department of Energy when I was there, and I was being asked to help determine what assets and devices were impacted by a certain vulnerability, which meant I needed to figure out what that component was that had that vulnerability. And I immediately realized that we just didn't have a way to figure that out for compiled code assets, like things that were already deployed and already out there running. And then you can't mess with the availability of ICS devices in particular. And so then we had to start reverse engineering firmware and things like that to try and figure out where are these components and what components are in this thing. And so that was just a huge gap because we just couldn't answer those questions in any meaningful way. And then when I was at Cylance, when I was working with you and for you for a good while, doing a lot of the work we were doing on the IoT firmware and embedded team, we were working with big automotive manufacturers and ICS manufacturers and medical device folks and all of those people. And those very large organizations had a desire to know this stuff. And all we could do was a handful of devices per analyst per year. And so the scalability piece was not there. The automation piece was inconsistent. And so to me, that it was that kind of confluence of experiences that helped me identify this gap and have the insane decision to try and go and fill it on my own.
Huh. And what was the reaction from the customers when you brought this problem to them?
Yeah, most of them have a visceral reaction is probably the best way to say it. It's a lot of information. You're giving them a lot of net new risk data that they feel like they have to action and make a decision about every little thing. And it's really our job to talk them off the ledge in a lot of ways and be like, listen, everyone has this problem. This is not a you problem. This is an industry problem. But without this visibility and acceptance, it's never going to get solved and addressed. But it's like everything, right? You're always going to have this crossing the chasm dilemma where you're going to have the early adopters who are just all in and want to be on the innovative edge, and then you're going to have people who no matter how much value you can generate, are going to adopt something later in the stage. But, as time has gone on, even over the last 4 or 5 years, acceptance of this data has become significantly greater, which, thankfully is the case, especially with what's going on now with the trivia incident and the light LLM incident recently. People are realizing, okay, I have to have visibility into these things because the attackers are going upstream. The attackers are really shifting left. And there's this illusion that if the attackers are shifting left, well, then so should we, partially. But if the attackers are shifting left, that's more of a reason you need to shift right. Because if that stuff has been pushed into production all over the place, you can shift as left as you want to go. The horse is out of the barn. You need to go figure out where those components are in the final built products that are now downstream. And you can't do that from source code analysis tools. So Ben, where do you see organizations getting stuck after they generate their first SBOM?
What do they do with it? How do they contextualize it? What's the point? Okay, great, I have this SBOM, now what? And does this solve my problem? Does this reduce my risk? How does it reduce my risk? What are the other things that I need to be thinking about? Generally some version of that, right? It's like, okay, great, we did this because we had to, now what? Right? And so helping them understand, especially from a product security perspective, right, what they need to do, that is almost always the next question. Okay, great, we've got this, now what?
Yep, I have an entire presentation that's called I have an SBOM, now what? Literally. And it talks about that exact dynamic because it's taken a while to kind of figure this out, I guess, actually, which might be kind of a silly observation, but building the technology that's capable of reverse engineering these things and generating SBOMs and enriching them and all of that is it's a non-trivial problem for sure. But what we've kind of realized is the real challenge is what you do with this data once you have it. How do you operationalize it? What integrations do you need? What value prop can you create that's net new for all these different use cases like third-party risk and incident response and threat hunting? So it's probably the most important question in this space, and it's one that I think is being answered in a much better way than it was in the past. So
and a lot of times we're seeing like organizations that have binaries and they have applications that they're developing and having to create from, having to review the source code, things of that nature. What's the difference from your perspective when building or generating a bomb from a binary versus source code? And how does that fit into the overall ecosystem?
I think there's a place for both. In fact, I know that there's a place for both. We're never someone that's going to advocate for you should not do source code analysis or generate SBOMs from source code. It's kind of a silly opinion to have. But the advantages of doing it from compiled code is, just number one, it's the actual thing. It's the actual thing at the end of the day. It is the product you have. It is the thing you are installing. You're not installing source code. You're installing this application, this firmware image, this container, this whatever. And so any issues you identify from the compiled code analysis, you have a level of certainty are actually there. Not to mention, your vendors aren't giving you all the results of the issues they find from a source code perspective, right? That's just not the way that works. And so the other things you get are